So hey guys, we're back with another video, and this time we're dealing with improper fractions. Now up till now you may have noticed that anytime we look at a fraction, by the way they're called proper fractions, the number in the numerator is always greater than the number. It's always bigger. Sorry, no, let me get that right. The number in the denominator is always bigger than the number in the numerator. Let's see how that looks. Let's say you had a block with 5 sections of it. 4/5 is a fraction because you're picking 4 out of 5. So is 3/5, so is 2/5, so is 1/5. They're all fractions. They're all part of the whole. That's what a fraction is. If you had, say, a segment with 7 sections, and you wanted to pick something out of that, you could pick 6 out of 7, that's a fraction, 5 out of 7, 4 out of 7, 3 out of 7, and so on. If you had 8, you could do the same thing. You could pick 7 out of 8, 6 out of 8, 5 out of 8. You're picking some of the segments out of the whole. And when you do that, that's called a fraction. And that's why the numerator is always smaller than the denominator, because you're taking some of the whole. So, what is an improper fraction? Well, in an improper fraction, the numerator is actually bigger than the denominator. Don't know whether you've seen this before, but here are some examples. These are very different from the fractions we saw in the first ever video that I did in similar fractions. Here you can see it, where everything is lower. Every numerator is smaller than the denominator. Now in today's lesson, what we want to do is show how to go from an improper fraction to another number. In fact, if you've seen the previous video, which I'll link to in the description, we were talking about mixed numbers, and an improper fraction is just another way of writing a mixed number. And today we're going to see how you can do this with a few examples. Now, before we talk about what rules you need to know, I want to discuss a very, very important factor. And how we can do this is using the example of a clock. Now, in a clock, when you use the term quarter of an hour, what does that mean? Well, we have this picture here. We see that a quarter of the segments is taken up, one, and that is the equivalent of the fraction 1/4. When we use the term half an hour, what does that mean? Here we can see it means 30 minutes, which is 30/60, which is half an hour. You should know that from your equivalent fractions. That means half of the thing is taken up. Now what happens if you have quarter of an hour, but then you want 4/4 of an hour? Well, that's 1, 2, 3, 4 quarters of an hour, which is, we would write that as 4/4. But notice, that's 1 hour. What if we wanted to do half an hour times 2 halves of an hour? Well, that would be 2/2. And you know that 2 halves is 1. So what are we saying here? Well, when the numerator is the same as the denominator, that means 1. That's number is 1. So 4/4 actually equals 1. As you can see, 4 times quarter of an hour is 60 minutes, and that makes 1 hour. 2 halves, which is 2/2, that makes 1 as well. So this is an important fact to note, that when the numerator and the denominator are the same, this means 1. It means the value you have is 1. So basically what you need to do is, first of all, ask yourself, how many ones are there in this fraction? And once you worked out how many ones there are, that is how many times you have the numerator and the denominator that are the same, you take out all those ones and eventually you'll be left with a fraction. And you add all the ones together and then you add the fraction to that, and that will give you the mixed number that you're looking for. Let's take the example we had in the thumbnail. We were given the improper fraction 7/5. So now we have to ask ourselves how many ones there are. Now let's take a look at this diagram and let's start adding segments to it. This is 1/5, 2/5, 3/5, 4/5, 5/5. So we know when numerator and denominator are the same, that equals 1. We've got 5/5 so far. That means we've got 2/5 left over, and that's going to look like this. 2/5. So 5/5 plus 2/5 is 7/5. You should remember that from our video on similar fractions. So we've got one block of 5/5 and one block of 2/5. 5/5 plus 2/5 equals 7/5. But if we look at the first one, it's 5/5. Numerator and denominator are the same. So this equals 1. So what you would do is put that one aside. That equals 1. And then when you find your leftover fraction, which is 2/5, you add that to it. So this is actually 1 plus 2/5. So what we're saying that 7/5 equals 1 and 2/5. Let's repeat that again if that was a bit too fast for you. You have your improper fraction where your numerator is greater than the denominator, and what you do is you find out how many ones there are. So what you need to do is you keep taking segments out until you get 1. This is 5/5. You've taken 5 away. How many have you got left over? You've got 2 left over. So there you have it, 2/5. And we know 5/5 plus 2/5 equals 7/5. But the important part is 5/5 equals 1. So you can change that to the whole number 1. And then you add the 2/5 to it. There you have it, 1 and 2/5. So 7/5, which is the improper fraction, equals 1 and 2/5. And this is how you turn an improper fraction into a mixed number. I'm going to do one more video where we can do a few examples just so that you can get used to this, and then we'll move on to another area.